voice is, it looks like I was singing a little bit too much, but I was not. I was just having a cold a few weeks ago, and still it's not everything good. So I'm not going to start to share the screen. Okay, I think you can also see my presentation. So today I wanted to talk to you about the learning on scientific language and how much do we really actually know about that. Just before Michael talk about the nice building, so on the right side of your screen, you see the main parts of that building. And this is our main building from our university, which is pretty much in the middle of Munich, which is in the moment pretty rainy, but we're looking forward to this next weekend where tomorrow 13 Christmas markets are going to open, and maybe next week we're going to have some snow. So I would like to take you to kind of like a little bit of journey about the work that I was doing in the last years, and also the reflection about those works and publications that we have. So as I said, it is about the learning of scientific language and how much do we really know. And actually the main point is about, oops, sorry. And the main point is actually about how much do we really know about it, and do we really know everything about it, and well, that's what we need to know. So let us start from the theoretical framework. At the beginning, we were looking for about different methods which can make chemistry lessons more language sensitive, but also more language supportive. So our main point was not only to make everything much easier and simpler for our students, but also to support them how they can learn language in chemistry classes. Now I'm talking also about the German language, how they can learn this language in chemistry classes even better. So on the left side, you can see different methods, different ideas, how teachers can change or prepare or adapt the methods which they can adapt into their worksheets or other materials that they're using, modules that they're using to make their lesson more language sensitive and more language supportive. As Michael already said, I was working for a lot of years together with Peter Charles from University of Limerick. And one interesting quotation was for me when he said that students are not molecules. They're all different and they not obey universal laws. And this is true. So we have so many different students. So that means that all the methods that I just presented to you a slide ago cannot always work for everybody. So that means we have to make this language thing, let's call it, more inclusive, so that I can also reach all of the students that I'm having. And this is what we made like about 4 years ago as our topic, and wanted to develop materials and units which make all of students, it doesn't matter how good or bad their scientific language is or knowledge of scientific languages, and also German language skills are, to make it possible for all of them to study and to understand and learn chemistry. So coming from this, we developed the integration of the methods. And the main point is that we need to have structural learning settings with intuitive learning materials. So it was really important that the students, when they get materials, it doesn't matter if it's the worksheet sheet, if it's a lab report or similar to this, that it is completely clear for those students what do they have to learn, without asking the teachers, without asking any support, without asking anything. And only when this is possible, only then the support that is needed when it comes to content knowledge, to understanding, is possible. And this support has to be simple and direct. So students have to know exactly how they have to use it, how they need to use it, but most of all, on which place in their studying and their learning they have to know. We found out in the paper that you see on the bottom of the screen that only then it is possible for our students to work cooperatively, and only then it is possible to work using inquiry-based learning education. From our units, we know that it is possible to go into open inquiry as well, and to have active participation from all of the students in our chemistry laboratory, or also chemistry classes. So this is the point when it comes to the students in our classes. But it's not only them. We have also the teachers that are actually forming everything and try to do everything. So we were discussing about pedagogical scientific language knowledge, which we define as a knowledge of scientific language related to teaching and learning chemistry, focusing on different scientific topics and contents. So this is very simple, let's say, definition, but doesn't really say about the facets, about the elements that actually the pedagogical scientific language knowledge contains. So starting from this definition, we actually went and checked what is going on in the literature and tried to find out how this language could be. How can we put this language together? And from the literature review, my PhD student, she finished her PhD, Corinna Mönch, she developed a module which is coming from, as I said, from the systematic review, presenting which is everything possible, or which is everything, or which are the elements that are contained in the model of pedagogical scientific language knowledge. I suppose a lot of you are now thinking about the model of PCK, which we rely definitely on it, showing that curriculum knowledge, pedagogical knowledge, assessment knowledge, content knowledge, and knowledge of students is something that has influenced this knowledge, which has to be about the pedagogical scientific, which we define in pedagogical scientific language knowledge. Going from this here, we were thinking about, okay, how is this knowledge actually described? Because when I go and do my teaching here at the university, what exactly do I have to do? Or what exactly do I have to explain to my future teachers, or also my teachers that I'm having sometimes here for a visit? What exactly do I have to tell them so that they gain this knowledge, which we call pedagogical scientific knowledge? So how is this knowledge described? Starting from this model that I just thought presented to you, we went into the field and tried to ask, how can the pedagogical scientific language knowledge of chemistry teachers be systemized according to the categories resulting from the systematic review? So going from here, we had semi-structured interviews, which took, you know, how the teachers are. Somebody are very short, somebody are talking a little bit longer. So we asked them, how do you teach actually language? Explain, please. So we didn't really ask them a lot. And we also had some open questions based on the content representation, which is based on the work of John Logren and his group as well. So we actually just wanted to know from them what exactly are they doing or not doing maybe when they are teaching language. Starting from here, we had participants, 19 exactly, which are coming from different federal states in Germany. To be honest, this study, well, one of the good things at that point from Corona was that it was possible to interview the teachers who are coming from different parts of Germany. Maybe you know that in Germany we have different educational system considering to the federal states that we are living. So it also, you know, the curricula that they're having, it also influences a lot how the lesson is taking place and how the lesson is organized. The age of those teachers were between 27, so pretty young teachers, but also teachers who are for 55. 12 of them were female and 7 male, and they said they have 12 to 16 years of experience in teaching chemistry. I have to say here that most of the teachers that we're having in Germany are either teaching, well, majority of them are having also biology as a second subject, but it is possible to combine it with a different subject as well. For example, me, I'm chemistry and mathematics teacher. School types that they are teaching in is 15 are teaching in lower and upper secondary school, 3 are teaching exclusively in lower secondary, and 1 teacher is teaching only in upper secondary school. So that means students from grade, in Germany, we would say from grade 11 to 13. That means from age like 15, 16 to 18. We analyzed the interviews and tried to put it into the categories that we get from the systematic reviews and to see how can we exactly explain those facets that we are having there and what is possible and or not possible maybe to say about it, but also to see if this knowledge is really only written in the papers that we are having and in the books, or is there something maybe more which we didn't find out at all. So on the first glance, it looks a little bit same as before. However, now we have new facet, which is called the motivation when learning scientific language. The teacher were talking about that as well. And something which was not found in the literature, to be honest, I was very surprised about that, is about lesson preparation, knowledge about the lesson preparation and knowledge about follow-up after I did my lesson on something. To be honest, for me, as somebody who was teaching for 7 years in school, it was kind of interesting to see that lesson preparation didn't really, actually took place or was found in our literature. So let me go a little bit deeper in just some of the facets. If you're interested into more or better explanation about those, please just let me know. But also on one of the slides, you're going to see the reference to this. So when it comes to the, when it comes to the knowledge of providing a discursive classroom, we have, for example, a quotation saying, I think it is simple also to speak. Yes, if you want to understand scientific language also as unculturalization in the subject, then of course you also have to speak. This is then nothing different in language teaching. Also, the teachers were saying about not threatening an appreciative learning environment that we have to have. And the majority of our teachers were saying that collaborative group working is very important when it comes to talking or studying or improving or adapting everything when it comes to not only scientific language, but also German language. So the students are instances of control and scientific language role models for each other in this case. Sorry. Oops. The next one is knowledge of scientific language role models. Of course, everybody of us see ourselves as a role model when we are teaching. We want them sometimes to be so impressed and so motivated about the topics that we are having. Sometimes we succeed, sometimes not so much. And also when it comes here, that is the teacher was saying that they have to be convinced that there are also other scientific language role models. Some of the teachers were mentioning especially social media and the people who are doing experiments on TikTok using little TikTok videos or on YouTube, especially because the students are not only studying at school and from the materials that you are giving them as a teacher, but also they're using a lot YouTube and similar things. So that means also those guys, those influencers, let's call them, are also role models for our teachers when it comes to scientific language. One of the teachers said that it is really important to say that using scientific terms consistently. So she said it is important that you yourself as a teacher always use the same term correctly and always use the same term. And this is something, to be honest, I'm not really familiar with all of the details of English language or teaching in English or teaching in English in school, but in German, it is really, really crazy sometimes, to be honest, because we have a lot of words that we're using for one phenomena, and it is important to stay stuck, let's say, on that one. And which is really interesting that one of the teachers, for example, said using scientific terms casually and explaining them at the same time. For example, here, so I say, for example, so here now an electron donation takes place, so an oxidation. So she's giving the term, but also giving a definition of it as well. And finally, the one that we only found in our interviews is knowledge of lesson preparation and follow-up. So the teacher here said that we should be very selective on scientific terms, importance and the definition of those terms is important. We had some years ago a study and somebody was counting how many new words are coming in the typical school book, chemistry school book that we are having in German. And it came out that 25% of the words that are using in the books as called as a scientific language are used just one time. And the question is, do we really need that? And also it was standing that every 9th word in such a typical student book, school book that we have in chemistry can be defined in scientific language. So this teacher is saying that she she thinks that nobody has to learn all the scientific words, and also that she's really reflecting on that only, those words that appear only once, they, should not take place in the lesson. One thing is that when you're preparing the lesson, then you have to focus and have an objective and have an aim in your lesson, also to focus on scientific language, to put a definition. Then today in this lesson, this and this will be done. For example, new words should be adapted. The students should use this word, I don't know, 5 times in different contexts or something like that. And this should be as defined as a learning objective that you are having while you're preparing your lesson. And checking materials from scientific language use. This is especially for the teachers in Germany. As I said, I'm not sure how it is in the States, as I saw some people are from the States, or in the UK, that we're collecting from here and there sometimes materials, and there are a lot of mistakes sometimes. And we have to check that everything is really in the place and everything is how you actually prepare your lesson to have this continuous usage of one word for one thing and not different words, or especially maybe different pictures when it comes to that as well. So going from here, we were thinking about fostering scientific language awareness and pedagogical scientific language knowledge of chemistry teacher educators. This is one point, because some of the teachers, this was not put, of course, in the model, but they were saying, for example, from their university time, that they saw that when it comes to chemistry teacher educators, meaning somebody like myself, who is working in chemistry education, but also pure chemists, that we also put this idea of scientific language and methods of how to learn scientific language in the classes as well, and foster and connect all teacher knowledge bases that shape pedagogical scientific language knowledge, as well as pedagogical scientific in itself in university teacher education. So going from here, we decided we have to give a seminar, we have to do something and try to change this. So what we did is, by using participatory action research over the period of 3 semesters, we developed a module which we are using also now here at this university to foster their pedagogical scientific language knowledge. So we identified the problem, as I mentioned before. We put together a development team, which is containing not only us, but also people who are responsible or who were at my old university responsible for teaching second language, German second language, but also from a German department. And then what we did, we developed material, we implement them, we did evaluation. At the end of the day, we reflected it and revised it in 3 steps at the end of the day before I moved to Munich and then took the materials now with me here as well. So how does it look like? First of all, we have a preparation. We want to make them sensitive in terms of language heterogeneity and scientific language. So we want to show our students or our pre-service teachers how important it is actually to take care about that linguistic heterogeneity, and also to present them how difficult is it actually when you're not so good in language. So really easy topic that I'm doing, actually, I just start my lesson, or now it is a video in English. Of course, everybody speaks English, but yeah, some good, some not so good. And especially when I want them to answer some questions considering this video, it makes them very uncomfortable. It makes them very unsure about what is happening and what I really want. So this is something that we have as a preparation. When they're coming to our session, we give them an input about what points or what could be difficult when it comes to teaching and learning language, German, but also scientific in chemistry classes. And starting from here, they give a page of a typical German chemistry book from which we're using in lower secondary, and they start to analyze the materials, checking which could be the point that could be difficult for the teacher, for the students when they're teaching. They reflect on that and also try to put a concept map to see which words do I really need and which is really completely ridiculous to keep and I have to change it. So when we send them back home, they have to go to the preparation and getting to know more about the methods to foster scientific language. So the week later, when they're back at the university, the material that they had in the session one, they have to revise it. They have to change it. They're free what exactly they want to do about that. So some of them, they completely rewrite the pages. They make new pictures. They do everything differently. Some of them, they just add some materials, do maybe some help cards and so on and so on. But for us, it is very important not just to do and change, but also to reflect to us and explain why exactly this change do they see as necessary, and why do they see this change as something good which could help students. And at the end of the day, there is a follow-up task. So that means we give them different vignettes, which are collected during the years from as a teacher, but also as a student, because I'm not German native. So I was struggling with German at the beginning of my school time in Germany. So all those things we put together in the vignettes, and students and our pre-service teachers have to answer 3 questions. They have to identify the problem. They have to think about what could be the reason for this problem, but then also have to write down, if this would be your student, what exactly you would do in the classroom. So we did an evaluation of this. We had questionnaire interviews, and we also evaluated the vignettes, and we were asking ourselves, how good is this? So the questionnaires say there's thought-provoking, and they see it now as irrelevant. I have to add to this, when you talk about the heterogeneity in a lot of our classes, the students are always thinking about chemistry proficiency, like how good or bad is their content knowledge. They see methods and effective in supporting students, but pre-service teachers were unsure how really they can use the methods. I don't know what is really sometimes with our pre-service teachers, but often we hear, I don't have time. So please tell me that also in your countries that they're always answering that they don't have time to do something like that. It is not only the German thing. So from the interviews, we saw that it is good to have input about scientific language, high self-activity. They really like the concept map, reflecting on the connection of the concept of the words, and also they like the methods. But they wanted to have just clear layout of the methods presentation, and they wanted to have another tool for concept mapping, which we changed during the time. So from the vignettes, we saw that our pre-service teacher can identify scientific knowledge, but they're not really understanding what is going on, and they really sometimes struggle about what is going on there. So from here, we noticed that we have to go more into the practice. So that means when our student teachers are in the internship, also to focus on this point as well when they're doing classroom observation. But I was just asking myself, how do we really learn science? So what I presented to you is like methods and what you can do and how you can change your classroom and your teaching, but how do we really learn something? So looking to the chemistry class, we have multilingualism. So we have Chemish. This is something which I understand as scientific language. We have academic language, how we need to express ourselves. We have students with second language knowledge. We have language, a home language that they're using. And today I would like to focus myself on this Chemish. So what is actually Chemish? We call it the scientific language of chemistry, important for the communication in and understanding of chemistry, but unfortunately also is one of the major difficulties in teaching and learning chemistry. So not everything is always positive. But so these are the points that are coming or belonging to Chemish. We have scientific language like atoms and cathodes. We have signs and symbols, but also we have something like energy, laws, and volume, which we use, but also, I don't know, a lawyer as well. So Chemish is it learning of the first and the second language? This is a question as somebody who speaks now my third language is always asking myself. So starting from here, the question to me is studying Chemish or understanding Chemish, is this language acquisition or is it language learning? So Me, as a not native English, I try to understand those two words. And I have it here. Acquisition is something that is understood in the literature as natural subconscious process. So this is something transmit our language through verbal, but also non-verbal communication. It involves students in conversation with us, also, as I said, also non-verbal counts, and encourage them to use our language. Learning means is a result of directly interaction that instruction that I'm having in the lesson. So I have a basic knowledge, and often this learning of language is associated also with second language learning. Okay, good slide, good information, doesn't really bring me a lot forward to make some good solutions and make some changes for myself. So I was thinking, oops, I'm sorry. So I was thinking we have to check neurolinguistic point of view here. So language acquisition and language learning are processed in two completely different ways in the brain. So we have the Broca area in our brain, which is only actively involved in learning acquisition process. Whether on the other side, we have Wernicke's area, which is active only in language learning process. So completely different sides, completely different things. But we still don't know, do we do acquisition or do we do learning in this case? For somebody who is interested in biology and neurolinguistics, so that means we are talking about the blue part of this picture and the greenish part of the picture. And one of them, or maybe both, or maybe both of them at a different time, I don't know, are somehow influencing our lessons and what we have to do as a teacher, or we as a science educators, what we have to do exactly in our classes. I'm sorry, I cannot give you an answer because I have no idea, but this is something that I think would be interesting to find out. So from here, what do we really do now? I think we have to find the right term first. We have to talk, do we have to talk about acquisition or do we have to talk about the learning? And from there, I would like to go to neurolinguistic research and to see what part of the brain is really active when I'm teaching them oxidation, for example, or neutralization, or something similar. From there, I think I should reflect on the materials that I develop over the years for school and see, does it really match or do I have to adapt them? And only then I think that it could be possible to focus on teacher education as well. So leaving you with no answers, but hopefully with some ideas to think about, I would like to thank to you and to my little team. This is still a picture from Corona, and to my little team and to you for the attention, and hopefully for some good questions and maybe some ideas for the research. Thank you so much.
Find the right buttons. Thank you very much, Silvija. Thank you for sharing your insights and quite a broad spectrum of thought there in terms of the two phases of work that you described. I have two questions coming immediately. One is from Michelle, who talks about this is the vocabulary issue. So this is where you were talking about identifying specific vocabulary. Does that extend to assessment, or this idea of how students rephrase when they are asked to write about or talk about something?
So, can you repeat exactly? Does it?
Yes, sorry. So I don't know if Michelle is able to speak to that a little bit.
Requirement of using scientific vocabulary extended.
But while Michelle, if you're able to clarify that a bit, I will ask my question, which is around concept maps, because I love the idea of concept maps. So yesterday I was thinking about elimination reactions and all the terminology involved in what is essentially one simple organic chemistry reaction. And there's just so many words. And I'm just interested to think about, how do you help teachers structure concept maps so that they're useful to students? Because I think it's not often only the words, but it's the relationship of words with each other in this very specific context.
Well, to be honest, I was just on Monday talking about one module where you can use that. However, to be honest, concept mapping is not really that popular in German classes. So I also noticed that in my chemistry pre-service chemistry courses, that when I talk to them, they have to plan a lesson. They plan for this Monday, and then for next Monday, and then for next Monday. And then I ask them, what is the connection from Monday to Monday? And they're kind of like really, they call it even a unit. So in German, like Einheit. And for me, it's kind of like weird because I call a unit something that lasts at least a month. So that do I have that connection? So in that case, I could somehow put also that concept map as well. Yeah.
Yeah.
I found the question from Michelle. So if
yes,
it's
lovely, yeah.
your answer. So I think the problem is of rephrasing. Rephrasing is definitely a good method to do. However, we should not use methods that kind of cause avoiding of using scientific methods. Maybe in the beginning, it is good to use rephrasing, but also then start to use kind of methods to say, okay, this is good what you said, but for this we use the word so and so, and then encourage them the next time when they use the explanation to use that new word that they learned in that case. If I understand the question
yes,
right.
Thank you. And then we might have time just to squeeze in one last question, which is Michael. So there's a long text there, but I think the question is ultimately, how do you think we might usefully think more critically as educators, as teachers, about our language when we need to teach different and often incompatible models in science? So this sense of, I think he's talking about different words, but same word meaning different things in different areas of discipline.
Yeah, for example, interesting word for me is always oxidation. So because we have so different concepts that are behind that. And the point is, the students are sometimes confused. I also experienced that when you use the word atom, they have a different, so for example, my kids, when I was a teacher, they asked me, do I mean the same atom as Herr Orlik, which was the physics teacher, and they had atoms in physics like a year before. So we do have to be critical about how we can use it. I think the major problem is that our teachers, they were at the university, if they're good, for 6 or 7 years. So they were kind of into that scientific language and the way to talk about that. But then when they come to the students, sometimes it's really hard to not use that scientific term, but also go into explanation. So I think there also that explanation competence, which our student teachers should have, plays a role and should be important.
Lovely. Thank you. Well, all I can say is just like a GRC, which I'm not allowed to talk about, there was a lot of interest in the post-seminar discussion. So I'll let you chase up some of the messages in the chat. But for now, everybody, could you please join me in thanking Silvija for a fantastic opening talk? Really appreciate it.
Thank you so much. Thank you.